Welcome. Now we are going to discuss the distributions. That is we'll start with binomial distribution. But before that, let me tell you what is this distribution all about. Till now, we have seen that random variables are of two types, namely discrete and continuous, and they will have either probability mass function associated with it or the probability density function associated with it based on the type of the based on the type of the random variable. Okay, and we have some standard distributions. That is, if the random variable is performing some experiment of this sort, the mass function or the density function is going to be of this form. That is what distribution is all about. Okay, now we will start with some discrete random distributions, and we are starting with binomial distribution. Here, if you see, the first one is a Bernoulli trial. Bernoulli trial consists of only two possible outcomes. That is, either you will get a success or a failure. Okay, and to this success we associate some probability p, and of course the failure will have the probability 1 minus p, because what, the total probability is 1. Now that we have only two possibilities. Okay, now if we perform this thing, this is a Bernoulli trial. Okay, so it has only two possible outcomes. If you are performing this Bernoulli trial for some repeated finite number of terms, let us say n times, then that experiment is comes under modeled under binomial distribution. Okay, so when you are performing this thing for n times and you count the number of successes that you are getting. Okay, so the thing is that you are performing some experiment for n times. There is a guarantee, there is no guarantee that you will obtain success for certain number of times. It can be varying from, there is a chance that you will not get success at all. There is a chance that you will get success for one time, two time, till what, till in all the trials you may get success. This is also possible. Okay, now let us see in what, how do we get the mass function of this one. Okay, so you are performing this experiment for n times. Okay, and x is the number of successes that you are getting. Okay, let us consider the simple case. Suppose you are performing this experiment for three times. Let us take trial 1, trial 2 and trial 3. When I say you obtain one success, when I say you obtain one success, there is a chance that you obtain that success in the first trial and failure in the other two trials, or success in the second trial and failure in the other trials. This may be these three possibilities. So out of this n, you will have to choose this x number of success. Okay, that is why we have this binomial coefficient here. Okay, and you have obtained success for x number of times, and it implies that you have obtained failure for n minus x times. Okay, so the density function is given in this form. Okay, so this is the not the density function, mass function of binomial distribution. It is usually denoted as n and p. So remember, this b denotes the binomial distribution, and n and p are the parameters that are required to describe this distribution. That is, n is the number of trials that you are making and p is the probability of success. Okay, now let us look at some problems. Here in the first example, it is given that a coin is thrown 5 times. Okay, so I think, let me change this to pointer. Yeah, a coin is thrown for 5 times. You are asked to find out the probability that there will be exactly 4 heads, which means you are expecting success for 4 times. Okay, obtaining a head, let us consider that as the success, and we are expecting 4 success. In that case, our x is, so now what is the case? Our case is, here probability is what, it is 1 upon 2, isn't it? And of course q is also 1 upon 2, and we are tossing the coin for 5 times. Okay, and we are expecting the success to be 4. So if we just substitute the formula and find out the value, we are done. Okay, now coming to the second problem. Given that 20% of the items produced by some company are defectives, okay, what is the probability that a sample of 10 items from this company will contain more than 2 defectives? Okay, now if we identify a defective product, let us consider that as a success. Okay, so the probability is 0.2 and we have 10 samples, right? We are asked to calculate more than 2 defectives, not including 2 defectives. Okay, so we are not specified to calculate at least 2 defectives. It is given more than 2 defectives. So we'll have to calculate the probability p of x greater than 2. Suppose if it is specified at least 2 defectives, then we need to calculate probability of x greater than or equals 2. Okay, suppose at most 2 defectives means probability of x less than or equals to. Less than 2 defectives means probability of x less than 2. Okay, and remember, we know that the total probability is 1. Suppose if you have to calculate probability of x greater than some a, it is 1 minus probability of x less than or equals a. Okay, using this, here if you see, this probability of x bigger than 2 shall be written as 1 minus probability of x less than or equals 2. And here there are 10 items. Okay, we randomly pick uh, okay, we there is a chance that we don't find any defective. There is a chance that we find one defective. There is a chance that we find two defectives. If we just substitute the formula, if we just substitute these values in the formula, that is here nc0 p to the power 0 q to the power 10 minus 0 plus nc1 p to the power 1 q to the power 10 minus 1 plus nc2 p square q to the power 10 minus 2, and we know that p is 0.2 and q is 0.8. Okay, it is implied from this, right? If you just substitute these values, you will get this done. Okay,